This is the Pearson EDEXCEL IAL Mathematics, June 2022, Pure Math 1. Question 10 is the final question of the paper, and it deals with functions and calculus or cubic graphs. Right, let's get started. We're given figure 5 over here with a curve C. And this is our curve. And we're also given, let's do our curve in blue. We're also given the line L. No information is given for number A, the line L. All right, here's our curve. Find dy dx. We want dy dx. So number 10a, dy dx. So dy dx is the first derivative. First derivative, we take every single term inside the a is a constant, okay. We take every single term in our curve and we use the power rule to find the first derivative in each case. So power rule, if y is equal to a x to the power of n, then dy dx is equal to n times a, which is just na, x and n minus 1. Right, so we do that in each case. So our y was 2 over x3 plus 1 over 7. That's a 7. Really is x squared minus 5 over 2 x plus k. One step at a time. So following our dy dx, we have 3 times 2 over 3 x, and it'll be 3 minus 1, which is 2. 3 times 2 over 3 x squared. And then we do the same thing for the next one. 2 times 1 over 7 is 2 over 7 x, and 2 1 minus 1, n minus 1. So 2 minus 1 is just 1. Then we go 1, the invisible 1 over there, times 5 over 2. This will bring down the negative, is 5 over 2 x, and 1 minus, well, it's x0. 1 minus 1 is 0. So actually, we just don't have any x's there because x to the power of 0 is 1. And the k is the constant term. It drops away in the first derivative. Okay. Let's make that look a little bit prettier. And then a is done. So dy dx, 3 times 3 over 2 times 3, 6 over 7. 3 over 2 is 9 over, this was a 2 over, what did I do? Goodness me, copy down a 3 instead of a 7. Fix that. Okay, no, lots of 7s. This should be 6 over 7. 6 times 2, yeah, the 3 times 2 is 6. 6 over 7, x squared plus 2 over 7 x minus 5 over 2. And that suits my answer in the mark scheme. So fantastic. Number B. Some information is given about the line L. The line L, which is shown here, is a normal to the curve. Okay, at point A, with the x coordinates of minus 7 over 2. So number B asks, show that the x coordinate of point B is a solution, one of the solutions of the equation, of this equation. So one of the x's of this equation is going to be the x coordinate at point B. here's our point B is on L and it's also on the curve. And point A is on L and it's also on the curve. And it's a normal to the curve at, so what is a normal to the curve? Well, normal to the curve is the 90 degrees angle to the tangent to the curve. So if we were to imagine a tangent to the curve over here, okay, but the tangent should touch the curve once. So let's draw that again. Try that again. So if we were to imagine a tangent to the curve here, let's just pretend that that's touching at exactly that point. Then between the tangent and the normal, which is L, there's a 90 degrees angle. Okay. So L is a normal to the curve, and we know that it's 90 degrees to the tangent to the curve at that point. And so we can use that information. So what do we know about curves that are 90 degrees to each other? Well, the gradient of the normal, which is 90 degrees, to the gradient of the tangent, m showing m is small m shows is the letter we use for gradient, must be equal to -1. So this is our proof. We know this. So we also know that the first derivative, the dy dx, of the first derivative of the curve, so of C, its gradient. No, wait, let me rephrase that. The first derivative is the gradient of this of C at any point x, at any x. Okay. So if we take this logic, we can say that the dy dx times by the gradient of the normal must be equal to -1. Okay, so I just switched the gradient of the dy dx, whoopsie, I put into where the tangent was. Because we know that the m of tangent is equal to dy dx. So good. Still further, well, information was given. We haven't yet used that x was -7/2. Well, x is -7/2 at point A. So we know we have minus, let me copy this correctly, -7/2 and some y, which we can assume is 0 because it's on, no, we can't assume it's 0, some sort of y. Okay. So what does that mean? It means that your first derivative, which is at that point, has the x value of -7/2 as well. So we can sub in x equal to -7/2 to our working. And then we'll only have one unknown. Let's see how this looks. So starting with dy dx. dy dx is above here from a previous question. So dy dx is 6/7, but we're subbing in the value of -7/2 because we know it's true at that point. We know that x can be that at that point. So we can use that information, 7/2. Okay, squared. Plus 2/7. Oop. No, 7, not 3. And we have -7/2. Another x there, -5/2. So this is our dy dx, first derivative. And all of this, we need to times by the m of the normal. Ooh, this will get us -1. Okay. So all of this was the goal of this. We just lost track of my goal here. My goal was to prove this thing, prove that the x coordinate of point B. Okay. So we're trying to get the x coordinate of point B, and I started off by trying to find L, trying to find the line L, so that we can solve for B because it's on the line L. That's what that was my or at least plan of attack so far. Let's see if it gets us anyway. All right, so carrying on with this logic, all of this on the calculator, and I get 7. 7 times the gradient of the normal, for, just for teaching purposes, you don't have to write this down every time, is equal to -1. You divide both sides by 7, and the gradient of the normal is equal to -1/7. Okay, so we have the gradient of the normal. What does that mean? Well, this line here is our normal. This line is our normal to the curve. And we know that at point B, which is the point we're looking for, is point B. The gradient is, we know what the gradient is now. We've got the gradient at the point B, and we've got the gradient at the normal. It's the same gradient. Okay. I started this off with trying to get the line L, but I think we can, just with the gradient, we can probably solve this now. Let's take a look. So if we have dy dx is here, this is our dy dx, and we know that dy dx is the gradient of the normal. So at point B, the gradient will be equal to dy dx. At point B, the gradient will be equal to dy dx. So at B, dy dx will be equal to m of the normal, which is equal to -1/7. Okay. So let's just sub in values for this. We have a formula for dy dx. We have a formula for dy dx, and it's 6/7 x squared plus 2/7 x minus 5/2. And this is equal to -1/7. So look at the question again. We're not quite looking like what we want. We want this 12x squared plus 4x minus 33. So we're not quite looking there. But so let's take a look a little further. We want it to look like that. We want our formula to look like that. I'm going to bring the 1/7 over to the left. So 6/7 x squared plus 2/7 x plus minus 5/2 plus 1/7, well, equals to 0. Add those two. Let's see, we can do an LCD here of 14. 7 times 2 to get the LCD. So if we do an LCD of 14, this is already over 7, so we times it by 2/2. We times this by 2/2, and this by 2/2, and this by 2/2. The reason I'm doing an LCD of 14 is just to try and get rid of these denominators. So it's 12x squared over, so 6 times 2 is 12, x squared goes to the top over 14, plus 2 times 2 is 4 over 14, 7 times 2, x goes to the top, because it's x over 1, x squared over 1 goes to the top. 5 times 2 is 10. But, oh, nope, this one, no, let's do it. This was times 4, this was times 7, because we need to make 14. Okay, this one's times 7, we need to make 14. So it's 5 times 7 is 35. Whoopsie. 35 over 14. And 7 times 2, so 2 over 14. Okay. Nearly there. This looks a lot like the question. Add it all up. 12x squared plus 4x minus 35 plus 2 is negative 33. Drop the denominators. And this is the correct question. And we've proved that, where were we? So we proved that point B is the solution of the equation because the gradient was the same at point B. If it's on line L, the gradient has to be the same. So we used a gradient method of proving it. So if point B is in fact on line L, that would make its x's a solution. And the gradient is the same as point A, and therefore we've proved it. So that was answer for number 10B. Number 10C, following on, find the x coordinate of B and justify your answer. Okay. So number C, following on, so we have this information. What is the x of B? Okay. Well, you can just, usual way that we get the x's. So we can, so it's not an easy one to factor out. So let's see, 12 has the 12 and 1 factors, or 4 and 4 times 3 makes 12. 12 and 1 probably, I'm not going to try first. I'm going to try 4 and 3. And then I'm, also 2 and 6. Okay, so let's see what happens if we do 4 and 3. 4x, 3x, and 33 has the factors of 33 and 1, and 11 and 3. 11 and 3. Remembering we are adding together to get the, middle term, and we are timesing together to get the third term. So what have I got so far? I've got 9x and I've got 44x, and we want to make plus 4x. So no, too big. So that's too big. I'm going to try change to 2 and 6. I'm going to change, use 2 and 6 as our factors of 12. Factors of 12, 2 and 6. Right, 2 times 6 becomes, we have 6 times 3 in the middle, which is 18x. 2 times 11 is 22. Okay, so we want to make plus 4. This looks more like it. Plus 4 is 22 and 18. So remember, if it's if the third term is a minus sign, then the signs in the brackets will be different from each other. And the sign, the biggest, the one that times together to make the biggest one will take the sign of the middle term. So the sign of the middle term will go to the 22. Will go to the 22. So it'll be here. Okay. And then, excuse me, sign of the middle term is positive. There we go. And that's negative. Okay, let's write that up. So we get 2x. Of course, you can always use the quadratic formula. 6x plus 11 all equal to 0. Look at these two brackets. One of these brackets has to be equal to 0 for this to be true, because anything times 0 equals 0. So 2x minus 3 must be equal to 0, or 6x plus 11 must be equal to 0. Let's look at this one. So we take 3 to the other side, plus 3 on both sides, divide both sides by 2, and we end up with 3 over 2. On this side, we take 11 to the other side, minusing 11 on both sides, divide both sides by 6, and we get minus 11 over 6. The question was asking for B. So if I remember correctly, what is the x of B? So we don't need to get any y's, we just need to find out the x of B. And the x of b is just the reason I use this is this was the equation that gave that there's two places where it would be true for the x's. So that's how I was answering this question, because it had a hence also gives it away. So hint on the say hence, it's usually a follow on from the previous question, but the x coordinate b is going to be one of these, and b is positive. B is positive, so it can't be the negative one. Okay. So go back and we look, and we can only, so it can only be this one. Therefore, the x of b is equal to 3/2. Fantastic. That concludes question 10, and it also concludes the June 2022 paper 1 of the IAL. This is all this work. Fantastic. Lots of explanations going on here. Good.